Everybody, welcome back to another fun and exciting pre-calculus class. Today we'll be jumping into lesson 9.2 in your books, and you can find that on page 181. 181, bring it up here. What we're going to be doing today is we're going to be graphing complex numbers and the trigonometric form of the complex number. Now, maybe that sounds a little complicated, and hey, it's pre-calculus, so it probably is a little bit. But at least this first part, you should be like, hey, I can do that. That's going to be easy. So, what are we doing? The only thing that we really need to do to graph these, we need to take the x-axis, okay, and we need to convert that over to what we're going to call the real axis, okay? And then we're going to convert the y-axis over to the imaginary axis. And really, to be honest, that's all we have to do to kind of get started with this. So look down here, graph complex numbers, simply make the x the real and make the y the imaginary axis. When you do that, when you kind of convert those over, we're not going to call this the Cartesian plane. We're going to call this the complex plane. So really still using the Cartesian plane, but actually graphing complex numbers on it. So we'll call it complex. Now, look down here. It says complex numbers can also be represented trigonometrically as a distance from the origin called the magnitude. Maybe you remember back from the beginning of this class, and in geometry you probably learned a little bit about it, but the idea of magnitude. What is magnitude? Also, maybe in science class you learned a little bit about magnitude. What is it? Magnitude is basically the size of something, how big it is. And if you remember right, with an angle, the magnitude of the angle, you could have longer rays on your angle, but the magnitude is based in the degree or how big the opening is of your angle. So the standard position angle is called the argument. Okay, so you won't hear me say that very much. I just kind of want to go over that just so when you read it, or maybe you hear it someplace else, you will know what that means. But the standard position angle, we call it the argument. So make sure you kind of remember what those two words mean whenever you're reading them. The magnitude is the size of the angle. Basically, when we're talking about this complex, we're talking about the size of the angle from origin. Okay, remember it's from 0, 0 where the angle is going to start. The trigonometric form can also be called the polar form. All right, now this is not like Polar Express or something like that. Polar means, if you know what the word pole means, just like North Pole, South Pole, the pole is the center, right, of the sphere. The Earth's sphere has basically, it's almost like a center rod that goes through the middle. Now, it doesn't have that. If you go to the North Pole, you're not going to find a pole sticking out. Now, technically you will, because they've stuck a pole in the ice, but originally there was no pole in the Earth at the North Pole or the South Pole. So what you have is when you spin something, it's like it's spinning on this axis, right? This pole. And so think of it like the axis, right? Like the axis, the X and the Y axis. And now we're doing polar form, like poles, okay? A North Pole and a South Pole. So the concept here is a globe or a sphere, and we're going to be graphing on that. Now, not right now, but that's coming up in just a couple chapters. So we're going to be doing some graphing using the polar form, but this is kind of laying the groundwork for that so that you know how to do it when we get there. Trigonometric form, also called the polar form. Here's what it is. The polar form, or the trigonometric form, is when you have r cosine theta. Okay. What is r? Look down here. Remember, r is the hypotenuse in trigonometry, okay? So we have hypotenuse cosine theta plus hypotenuse imaginary. Remember, we're dealing in imaginary right now. Imaginary sine theta. So when you convert it to that, when you take it from its standard form, I guess you would say, or its complex form, and you turn it into trigonometric form, here's what you need to find. You need to find the hypotenuse, and you need to find the theta. And we're going to work on that in this lesson, okay? So when given a number in standard form, The r and the theta are found using basic trigonometry. How do we do that? Things like a squared plus b squared equals c squared, right? We have this equals, we'll just call it a plus b. And, that's usually opposite and hypotenuse or whatever, adjacent. And so we've heard different names for it. But a squared plus b squared, you know that as Pythagorean theorem, right? So that's one way that you can do it. The other way that you could do it is you could do that the tangent equals, or the tangent of theta. This is how we would find our theta. This is how we find our r. The way that we find our theta is we find the tangent of theta. What's the tangent of theta? Well, that equals the opposite over the adjacent. So opposite, in this case, we'll use b over a. And we could use instead here, we could use x and y, right? And y and x. Okay, I'm just using a and b, but it's really x and y. So what we would do, and the reason why I'm using a and b, because our formula for complex numbers uses a and b. And here we're kind of switching that over to trigonometry, and we are going to be using the x and the y or the a and the b. They're the same thing, okay? So the way that you do this, the way that you convert is by using trigonometry to do these two operations, and it'll switch it back over to the polar form. Now, what if they give it to you in the polar form? Look here, when they give you a number in the trigonometric form or polar form, a and b are found. Now we're going back to a and b because we need that for the complex form. They are found from using the hypotenuse times the cosine of theta and the hypotenuse times the sine of theta, okay? And so again, you should be thinking right here, okay, there's a y and an x right there. We're going to get our y and our x and our y is going to come out of that. Okay, so that's the idea, switching back and forth between polar and complex. So let's go ahead and do one of those. And on page 181, you are going to find example number 1. It says that it wants you to graph and write each complex number in trigonometric form. So this is where we're going from complex to trigonometric. So what's the complex form? 2 square root of 3 plus 2i. Now, it's really easy to graph it, right? So we just make this the imaginary and this the real. And so we go over on the real, 2 square root of 3. Say, what in the world's 2 square root of 3? Just do it on your calculator, right? Type in 2 times square root of 3 and hit equals, and it will tell you what it equals. And then you just go over that many spaces. You say, what do you mean? It's like gives me an irrational number. You don't have to be perfect when you're graphing these, okay? Just get it close to where it goes. You'll see here that they have it somewhere just shy of 4. It's like maybe 3.5, 3.6. Let's go to our calculator real quick and let's actually take a look at what we get exactly when we do that. So you do 2 times the square root of 3, and we'll hit equals, and we get, well, of course, 2 square root of 3. There we go. You're like, hey, what? So we get 3.46, or that's really close to 3.5. So if we go back over here and we look at this, so if we go over, right, 1, 2, 3 and a half, basically, there you go. It's right there between the 3 and the 4 where they have this plotted. Now, the 2i, we just plot it 2 up because I is the imaginary. So we just take the number, whatever the number is. You don't worry about the I because the I stands for the imaginary line going up and down. So we just go up 2, and there it is plotted there on 2.5 basically and 2 up. All right, so there is our dot. Now look at the angle that this is creating. Okay, remember the angle is always from origin here, so we're creating an angle right here from the y line, or from the x line, from the real line up here to the point. This creates an angle. Now, basically we want to know what angle that is, what was created right there. Now you can look over here if you want to and kind of follow along with me. I would suggest that you do that, but also I want you to write this in your notebook as I'm doing it. So you follow along with me as I'm doing it in your book, and that's really going to help you. So let's jump back over here to the computer screen and we're going to do this one. So what we want to do is, first of all, we want to find the R. And we can put our dot right about wherever it went, somewhere in here. So there's our triangle right there, okay? Now, we want to know what does R equal, because we don't know that. We do know what X equals, right? So X equaled 2 square root of 3, and Y equaled 2, okay? So we do know that much. Now, as soon as I put that on there, something should have popped into your brain, right? You should see the whole idea of the 30, 60, 90 triangle there. Maybe not. Maybe it's been a while since we've worked on this, so maybe you do have to figure it out. But what we want to do is we want to find the R squared by saying, okay, what's A squared? Well, A is this one, so we're going to have 2 square root of 3 squared, and that's going to be the whole quantity squared, plus 2 squared. Just leave this I alone. We don't need that because that just tells us it's going up and down, okay? So there we go. Now we need to plug this into, now that we've got it plugged into the Pythagorean theorem, we need to plug this into our calculator or whatever to find out what the R equals here. You can do it a couple different ways. Probably the easiest way is to, really the easiest way is just to have this memorized. And so you know that basically the R, the hypotenuse, is going to give you what? Well, if you look back at the front cover of your book, if we have X over X square root of 3, right? We cancel the X, it's going to give us 1 over the square root of 3. So R equals 1 over the square root of 3. You can also do this by just plugging this into your calculator and letting it give you the answer. You can see what they did in the book. There's different ways that you can do it. Let's just do the math, okay? And let's just see what the math gives us. Let's just square root both sides right off the bat to get R equals the square root of this. Okay, and then we're going to get the plus minus, right? But one thing in trig, remember we always said that R is positive, so we really only need the positive value of R, but it'll give us a plus minus value right here, but we only would take the positive. That's all we need. All right, so we do this, we go through this, and we basically solve underneath of this and then take the square root of it. What is 2 square root of 3 times 2 square root of 3? 2 times 2 is going to give you 4. Square root of 3 times square root of 3 is going to give you the square root of 9. We know that the solution to 9 is 3. 4 times 3 is 12, okay? So we're going to get 12 there plus 2 times 2, or 2 squared, is 4. So we get R plus minus, and this is all still in the square root sign, and that's going to be the square root of 16, or R equals plus minus 4, or just R equals 4, because remember, R is always positive. I'll write that up here in the corner, R equals 4, okay? Now, we know what R is, but what else do we have to find? We have to find the theta, okay? We don't know what the angle is yet. And again, maybe you already do, you should already know, to be honest. When we have our 30, 60, 90 triangle, we know that this is going to be a 30-degree angle based on these two pieces and based on that equaling 4, okay? Because this is 2x right here. The hypotenuse is always 2x, right? If you're trying to remember that, go back to the front cover of your book and look through that. But you should be able to determine, just out of kind of knowing the 30, 60, 90 triangle, that our theta does indeed equal 30 degrees. If you don't know that, then you can just plug in here, like you could do the tangent of, what is the tangent of theta equals, so we're going to do tangent -1, because we want to get what the tangent is of our cosine over our sine or our y over our x. So what is our y? Our y is 2. What is our x? It is 2 square roots of 3. This cancels to 1/3. And then when you plug in tangent on your calculator, we'll do that real quick. So plug in tangent, well, inverse tangent of 1 divided by square root of 3, and that is going to equal 30 degrees. There's our 30 degrees. You can do it on your calculator, it's fine, but it's much faster if you just memorize that 30, 60, 90. So there we go. There's our r and our theta. Now what we want to do is we want to put it into the proper form. Now you have to have that memorized, right? So go back there and let's take a look at that. What was the proper format? The proper format was, there it is. Circle that. R cosine theta plus r imaginary sine theta. So you do 4 cosine theta. What's theta? 30. And you can put that in parentheses, but plus 4 sine of theta. All right, and there you go. That is now in the polar form. Now, one thing that you could do is you could factor this 4 out. So you could do 4 comma cosine 30 plus sine 30. And that would be fine too. Really, either one of those is a fine answer. I always like fully factored answers, so that's probably the better answer right there. But you could do that either way. I'm not going to take the time here to go back through every one of those, but they give you basically here, you're looking at, that was the first one that they gave you. Then you have this -3 plus 3i. You just do the same thing with all of those. You just work your way around it, and here they show it right here. Notice it does say, then this is interesting, because I said here where you only needed the positive. Look, they did a negative angle as well. See, they have the -4 right there. But look, pair arguments and angles according to the graph quadrants, it is customary to report the form with the positive magnitude. So you only need to do the positive, and that's where it kind of goes back to r is always positive, so that's just going to kick out the positive there. So just write your answers using the positive r, and that will work out for you. See here, they do it with the -3 plus 3i. I'm not going to go through all that. You can look at it if you want to. Let's skip down here quickly to example 2, and we'll finish up right there. All right, so what are we doing here with example 2? Example 2, they give it to you in the polar form, and they want you to take it back to the standard form. All right, so we're really going to do the same thing. Let's kind of jump back over here, and let's look through this one. So what we want to do is we want to determine, okay, what do we need to do? One thing that I would do first is I would apply this. I would factor this back in. So we're going to get 2 cosine of 150 plus 2i sine of 150. So we really need to find two things here, right? We need to find what does a equal. So this is a, right? And then this is going to be b. So this is our a and this is our b over here. We need to find out what those things equal. So what we need to do is we just need to solve these. Okay, it's really that simple. You can look in your book. They solve it without a calculator. You can see how to do it right there. Basically, you're just using your trigonometry. You're using your 150 angle. You should know what 150 equals. You plug it in there. I'm just going to be honest, it's going to be a whole lot easier and save you a lot of time if you use a calculator to find this. Some of your teachers may not like you to use a calculator. That's fine. Make sure that you know how to do it without one, but this will just save you a little bit of time. I love the unit circle, so I always go back to the unit circle. That saves me time. I don't have to click all the buttons on my calculator, but we could just do it like this. 2 times the cosine of 150, and throw that on there, and we say that equals, there it is, negative square root of 3. Okay, so negative square root of 3, and then we would go, and so that's going to be your answer for your A. and then we would go back and find the answer for your B, and we'll clear that out, and we'll do 2, and the i's, we're just going to kind of leave that alone because we know that we're working on the y-axis right now. And so we'll do 2 sine of 150 equals, and that gives us 1. So the answer would be 1i, or I1, or just I. That's all you need. Okay. All right. So there it is in complex, and there it is in trigonometric. So that's how you do it. You just transfer it back and forth using our sine, cosine, tangent, using trying to get r, using Pythagorean theorem, all the things that we've learned about trigonometry at this point. You're going to use those there to kind of get back and forth between polar and complex form. The graphing is not too bad. The math there is not really too bad either. You can use calculator to transfer back and forth. So I think you should be fine. Here's what's the problem. Here's kind of the stick right here. The thing that you're going to get in trouble with is make sure that you are only using positive r's. Don't worry about the negative angles. Yes, some of them are going to give you a positive negative angle, but you don't need the negative angle. So only answer in the positive angle, but do pay attention. Remember, all students take calculus. We need that, and we need to remember what is in each one. If you put a negative sign, it's supposed to be positive, it's going to throw everything off. So make sure that you know, just jumping back over here real quick. Like in this one, make sure that you know all students take calculus. Make sure you know where it is. It's in the first and in the third. And if you do that, if you can, kind of put those into the right quadrants, you're going to end up getting the right answer. But really, the easiest way to do it is when you get the answer with your R, you're going to get a positive, negative. Only take the positive, and that should just give you the positive answer as you solve it out. Okay? That's all I got for you. Hope you learned something today. If you missed anything, slide it back there, take another look at it, and try some of these practice problems, see how you do. All right, we'll see you later. Have a good one. Bye-bye.